as well. It's actually AI research is booming. We have more than 100,000 peer-reviewed publications on AI matters, including IEEE publications as well. And in the same time, we also have AI systems which perform increasingly well. Training time, for instance, for classifying images on a standard database some years ago was six minutes. Now it went down, as you can see. And of course, this is also related to hardware advancements, so accelerator chips, which have been designed specifically for machine learning applications. We also see that AI systems surpass human performance in some certain areas. So here, for instance, in natural language processing, you can see that the performance of the system surpassed the human performance, which is the red line. And even in the next version, it took even less time to surpass this human performance, even if the stake is set higher. So, of course, a lot of applications. So I don't think I have to tell you here about all the possibilities in healthcare, natural language processing, and so on. There are, of course, some challenges as well. And I will just give you one example, namely that of the representation of us humans in the digital space. Basically, their AI also enables to take more parameters into account. For instance, there was emotion detection also some years ago, for instance, based on heart rate on one parameter. Now, due to AI, you can take a lot of parameters and also combine them with non-personal data, different sensors and so on, and to come to a conclusion about the person. So, of course, and this can have a lot of implications as regards our access to information, access to services, to loans, partners even, and so on. So, of course, there is a lot of question around how well can we trust these systems. And I think this is also why we are discussing now the regulation of the AI, because it's the first regulation worldwide, or let's say a proposal for the regulation worldwide. Where does it come from? So what is the background to it? Well, first of all, probably you're also aware that in 2019, there was a proliferation of discussing AI principles. And as a matter of fact, also IEEE took part in our public policy group. We were part of the high-level expert group together with the Standard Association. We are still part of the OECD, of the Council of Europe, of UNESCO working groups. So a lot of international organizations have set out these principles that as you've seen here. This is just a summary, let's say so. And you see the not surprising principles of privacy, accountability, safety, and so on. And of course, this was the start, and I think it was an important start. Especially now coming back to a very recent paper I just read I think in the last days, from DeepMind scientists, which say that actually reward is enough. Reward is enough, and they say that the generic objective of maximizing reward is enough to drive behavior that exhibits most, if not all, abilities that are studied in natural and artificial intelligence. So they drive the comparison between, let's say, the natural environment, so a squirrel, in its aim to maximize reward, namely to survive. It learns a lot of other things as well, such as planning and so on. And they say that actually the most scalable and general way, they claim, is to arrive to a general artificial intelligence is through reinforcement learning agents that interact with the environment and maximize rewards. Now, of course, this is debatable. There are already some reactions to it, but I think it has also a deeper meaning, let's say so, because if we are thinking about rewards and that reward is enough, we have to think, well, how to define the reward? And maybe we need really some new metrics of success. So until now, especially we as technologists, for us, let's say we maximized or optimized the system for performance. And of course, if we take again a very recent study, which came out last week from the Pew Research Center, well, they're not very optimistic. They say if nothing happens, then ethical aspects will not play a big role in system design. They say that still companies will try to maximize profit or to have social control. So the question is again, and actually we have a working group on IEEE on how to redefine these new metrics of success in the age of AI. Do we need to take into account also well-being aspects or environmental aspects and so on? And I think what is also interesting, and also coming back to the EU regulation, I just wanted to highlight that actually with the draft regulation, so the draft regulation is about let's say the trust aspect, but it comes in a package with the ecosystem of excellence. And the EU insists that, of course, they would like to push research and investments towards AI research that maximizes, let's say, some rewards, what they consider, and I think we consider as important, such as healthcare, sustainability, and so on. But I think what is also interesting is in the EU regulation is that they also redefined risk. So again, risk is for us, again, technologies mostly related to safety and security. And now we have for the first time risk which is defined in terms of fundamental rights. And we see that there are even, if you see at the top of the pyramid, some excluded applications, such as social scoring. We don't want to have something, the social scoring system, and as in China. Excluded are also manipulation systems. And then they go down and define high-risk applications and limited risk applications. And also, of course, what they say, a lot of applications don't have any risk at all. What I think is also relevant for us as a technical community is that, of course, a lot of it is defined at a high level. And I think that probably for regulation, this is the only way to do it, because the technology is evolving as well as our, let's say, values. Imagine what you thought about being privacy when you were talking at the phone on the street, maybe, I don't know, we had phone booths, and now everybody's talking and that doesn't have any problem. So I think the technology as well, the values evolve. What I think, what is interesting here is that they left a lot on how to operationalize it and how to define transparency, accuracy, and so on to technical standards. And for high-risk applications, there are even horizontal mandatory requirements and conformity assessments that have to be done before you put these services, products in on the market. For limited risk applications, there are some transparency obligations. So, for instance, a user has to know that it is interacting with a robot or with an AI system. But even for minimal risk, they suggest to have voluntary codes of conduct. Now, the question is, where do these standards and conformity assessments and standards come from? So I think that what is important here is, and here it comes to it basically to the core of IEEE, if you want so, is to convene stakeholders. We are convening stakeholders mostly at, let's say, until now, technologists among ourselves. We were discussing a lot of technical issues. And I think what is important now, and this was the ethically aligned design, is to convene also the users and also the other, let's say, people affected by the system, and see what are the issues, what kind of, let's say, ethical values and so on are important and need to be taken into account at system design and later on. And we started talking with different communities. So here, for instance, there is ethically aligned design for businesses. And just to give you some example, what was important for them was to define an AI ethics readiness framework, to say, where am I actually in this framework? Am I just lagging behind? So maybe I'm aware of some of the ethical concerns, but there's no real follow-up, let's say, at the company level. Or am I leading? So that means that the value proposition is in line with the values of the potential users, and it's part of the company strategy. So coming to IEEE, so the way we started from the beginning, and I think it's very much in line with the EU proposal, is to make things concrete. So get from principles to practice through standards, which are based on convening stakeholders and building consensus. And what is interesting here is that we started building, besides technical standards like the Wi-Fi standard that we are now all using now, also these socio-technical standards. And when it comes to certification as well, so we developed certification criteria for transparency, accountability, algorithmic bias, and now we're just finalizing one on privacy. And of course, governance is also important, because these governance will determine the standard certification, best practices, and skills which will be needed. And just to give you some examples of these social, technical, and technical standards, you will see some here highlighted. The first one, value-based system design, which was just approved last week. So you see there are very recent developments as well of assessing the impact of autonomous systems, which was also approved this year. But you can see a lot of working groups on transparency, on algorithmic bias, on data governance, and so on. There are also some, let's say, also more general standards on age-appropriate digital services. As we know, 1/3 of the internet users are below 18, but a lot of services are not designed taking this into account, and as well as organizational governance of artificial intelligence. Now, coming to the technical standards, you will see that some of the standards are sector-specific, such as mobility or healthcare or manufacturing, finance, or here again, some of them are important for interoperability purposes, for federated learning, and so on, verification, and so on. And I would like to basically conclude with the certification program, because I think it's a quite novel approach to certification. As mentioned also in the regulation, certification is one basis for trust in products and services. And it is important to have an independent scrutiny, because a lot was done by independent boards, but it is important to have this independent scrutiny for high-risk application. What I think is important is to be especially adaptive and agile in this sense, because the technology is changing so quickly. So here in IEEE, let's say a concept-based approach was used that permit a rapid tailoring to a sector, and also it is risk-based in the sense that first risk is determined, and then the assessment effort is proportional to that risk profile. And with this, I would like to end and just say that in my view, the EU regulation, it's very much in line, let's say, with the IEEE tagline of advancing technology for the benefit of humanity. We can build trustworthiness by building trustworthy products. And one way to do is through standards, which gives, let's say, the designers and developers a step-by-step approach of what to do at system design and certification, basically to make sure that what was promised is really fulfilled. And it's very much in line with something like nutrition labels and so on, which is also about trust. Thank you. Let me stop sharing. Thank you.
So thank you, Dr. Clara. And with no further delay, we will go to Dr. Joerg's presentation. So
thanks a lot, Matthias. So first, thanks a lot for having me here. Special thanks for the invitation. My name is Joerg Osterrieder, and the presentation is joint work with Branka Haji-Micheva. She is one of my colleagues. I'm based in Switzerland at Zurich University of Applied Sciences, and I have a joint appointment in Netherlands as well. Let me go back to 1688. So we did have a financial revolution at that time, and after William III invaded England, and his reforms in England were based on the Dutch innovations. And we had the first government bonds issued in 1693, and the Bank of England was founded. And then soon after that, we had English stock companies which went public, and the central aspect was the emergence of a stock market. So that was the first, well, not the first, there was a financial revolution already in the 17th century. And today, 300 years later, we have the AI revolution, and you have to prepare your business for that. Then we have another financial revolution, how IT startups change the rules on Wall Street. Then we have the fintech revolution. Can it help build a better economy? And we have something which says transparency is the future of finance. So it seems we live in an exciting world, and the topic of this roundtable today is trustworthy AI. So transparency is one step towards having a trustworthy artificial intelligence. And I will quickly mention our COST action. COST stands for European Cooperation in Science and Technology. We got funding from the European Union last year. It will run for another 4 years. And the title is FinTech and AI in Finance Towards a Transparent Financial Industry. We didn't call it Trustworthy AI, but you can read from the title. We have AI and we have transparency. And you can see that my background is in finance. So most of the examples, most of the slides I will use are geared towards financial applications and the finance industry. So here's a bit more detail, but I will quickly skip over that since Katharina already introduced me. So I'm also the action chair of this COST action, and I have some industry background from Goldman, Merrill Lynch, Credit Suisse. And now I'm at Zurich University in Switzerland, where we work a lot with the industry on applied research topics. 10-second marketing. We also have a conference on AI in September. That's our flagship conference, and you're of course very welcome to attend and join. It's online this year. We actually, well, I hope everyone is fine with Corona, but there are some benefits because we have really international events nowadays. People are meeting from all over the world. They don't have to travel as much, and there's much more international and cross-border activity. So for this one, we will have participants from, last year we had 80 different countries. So this COST action has 38 European countries, and out of only Finland is missing, and we have a few international partner countries. So if anyone is interested to hear more about it, please just let me know. And we, of course, Portugal is on board, and Katharina is in the management committee for Portugal. And Bernadette, I've seen her in the audience. She is also representing Portugal. We have lots of events as well. I skip over that. And here the goals and aims, it's closely related to trustworthy AI. So if I jump in the middle of that slide, we have transparency again of AI, transparency in financial services. That is not just trustworthy AI, but part of that is that as well. So what is AI? All of us are using AI just because it seems we know what it is, right? Intelligence we know, artificial we know, so we just use AI. So one way of looking at AI is as a model, as a mathematical model. And what are models and why do I need them? So why do we need them? Because our reality is very complex. We want to describe complex realities. And if I go back to Aristotle, he said it's the mathematical sciences which exhibit order, symmetry, and limitations, and these are the greatest forms of the beautiful. So if you ask any mathematician, he will always tell you that. Robert Shiller, Nobel Prize winner in economics. I met him in London before he got the Nobel Prize, just shortly after he got it. He says in economics, he actually thinks it's good that we are moving away from mathematical models, which are usually very rational and which have a rational behavior. And he thinks that we need more insights from psychology. Then George Box, all models are wrong, but some are useful. And German philosopher, Georg Friedrich Hegel, the only thing we learn from history is that we learn nothing from history. So let's go back to the 17th century again. So this is Sweden, and at that time, Sweden was a very powerful European country. They have expanded a lot, and to keep the or extend the expansion, they actually built the largest warship ever at that time, the Vasa. If you have been to Stockholm, you might have seen it. And the problem was, well, it was also very expensive, but the problem is it just 1 hour after it started to sail, it actually sank. And why was that? There was a mismatch between the size of the ship and the ballast calculations. And if we look at this picture here, on the x-axis, the displacement of the ships, the size. On the y-axis, the required ballast, the red line. And at that time, all the ships, the size of the ships was here. So what was used at that time to calculate the required ballast was just a linear line. All of us know linear regression. And there was an extrapolation, and that's where the Vasa ship was. But it was not linear, it was the straight curve. So that's why there was such a huge error. So that's a linear model, and it's a very simple model, and it gives a lot of problems. So we know that, so we have to go to nonlinear models, which AI, if you go to the mathematical background, neural networks, they will be nonlinear. So key takeaways, we don't live in a linear universe. The linear models are not enough. We do have model risks, so models can be wrong. That leads us to trustworthy AI very soon. And they're all approximations of reality, and they're all wrong, right? If you look at from the right angle. I have one more example from recent times, from the financial crisis 2007. A slightly more complicated formula, you see, I just like it, but it was in the Wall Street Journal, and the Wall Street Journal said the formula that killed Wall Street. So that was one of the reasons for the subprime mortgage crisis in the US. And there's no artificial intelligence here, right? We will see very soon how complex AI models are. This is still a very simple model, and the simple model killed Wall Street. So models can be wrong, they can change over time, and they can have negative consequences. But what about AI models? Well, if linear models are already hard to understand, and I think AI models are just another category. Do we need regulations for that? Clara already mentioned a few things. So do we need them? Do we need to regulate that? So if we go back before AI, we have, in the finance industry at least, we have those Basel banking regulations, and you see there was nothing in the 70s. It started with a few pages, and then a few more pages, and 50 pages in the 80s, and then 100 pages of new regulations per year, 300. And then we had, just before the financial crisis, we had 1,000 new pages of regulation. And then for 2 years, they were under shock. They had to wait and think about what to do. And then it goes on and on, thousands of pages since then. And I think it takes one human person to like 80,000 years to read all those rules. And this is without AI. And the big question is now, where are we now with AI? How do we need to regulate, and how many pages do we actually need for that? So what is AI? Different angle from what we saw before. So that's the EU definition of AI. They have a high-level expert group. They say AI is software or hardware systems that are designed by humans, given a complex goal, act in the physical or digital dimension by perceiving their environment. So they know something about the environment, which is the data input. They interpret the collected structured or unstructured data. They make something out of that data. They process the information. And then they actually decide on the best actions to take. And then, of course, it can be symbolic rules or learn a numerical model. And they can, that's also the nice thing, they can adapt their behavior. How they, by analyzing how their environment is affected by their previous actions. That goes towards what Clara mentioned about the reinforcement learning. A second definition, a simpler definition, if you go to the Financial Stability Board, they say AI is a term that says it's the application of computational tools to address tasks traditionally requiring human sophistication. And machine learning is a subcategory of that. And here is an overview. We have AI, we have machine learning, and then we have those typical 3 or 4 categories: supervised learning, unsupervised learning, reinforcement learning. And then it falls under those 3 categories, but gets a different name, the so-called deep learning. When you are in the learning area, that would be the AI, at least in one definition. And then the other big part which you need nowadays, we would not be here without the big data analytics. We would not be sitting here now if we wouldn't have access to much more data than we have ever had before. And only with this data we can use those new mathematical models. So if you go to machine learning, here's the supervised machine learning. You have some training data, a duck, and not a duck, you have to tell them. Then you have your model. And then you have a new data coming in, and your model will tell you that's a duck. If you have the unsupervised machine learning, you just give the computer the data, and it will automatically categorize or cluster the data here, in this case, into 3 different categories. It doesn't know that this is a duck, but it knows those 3 are similar. And then we have the deep learning. This is the way deep learning mathematicians usually picture the model. The important thing is you have some input, then you have a model, and then you have some output. And in between here, you can make it as complicated as you wish. And reinforcement learning, we already heard that. You have an environment, you take some actions. Every time you take an action, you get a reward, and you observe the state, and based on the state, the agent takes the action to optimize the overall reward at the end of the time period if it's a finite time problem. And then I like this picture because a few decades ago, chess playing was considered AI. That's just here, you have a chessboard here, and this is just another way of representing those deep learning networks. As you see, you can make them as complicated as you wish. So it started actually in the 50s. Then we had this machine learning, and now we have the deep learning. And if you go into the deep learning opportunities or models, you have, is there a way of zooming in here? Yeah. So if you zoom in here, you have many of those different ways. They all have different names, they all have different features. And one of the unsolved problems at the moment is still, which model do I use? And then, of course, does this model work for the particular application? So history on the deep learning, we had the perceptron in the 50s, and you see at that time, the idea or the hope was that we will be able to walk, talk, see, write, reproduce itself, and be conscious of its existence. And then after the 50s, we had a few more things, complications, extensions of this perceptron, a very simplified model. Then even more, backpropagation is a mathematical technique which can actually help compute those models. In linear regression, it's very easy to come up with the optimal parameters. You have the input data, you have the output data. For linear regression, you even have a closed form solution, so you can just compute the optimal solution. Now, with this AI and the deep learning, we are in the numerical model where we actually don't know what the optimal solution is. We don't even know whether we found the optimal solution once we have a solution, once we have decided on an action. We don't know whether that's the optimal action. We just know that's something optimal which the computer told us. And then we go on. It goes on and on and on. More developments. Here there was some, the LSTM by Jürgen Schmidhuber. His brother is actually a colleague of mine. We could hire him 3 years ago. He joined our faculty. Something for time series or for something which has memory, models with memory. And then GANs, something I'm looking into right now to generate new pictures, new time series, to generate new data. In some fields, we don't have enough data. In finance, we don't have enough data to train all those AI models, so we need to generate more data. And then we all know those AlphaGo games and machine learning. IBM, which was beating, or the AlphaGo, which was beating the Go world champion. I have one quick comparison between the traditional world where we used to live in until recently and the new world. So this is one standard example. Even Nobel Prize was given for that. The capital asset pricing model in finance. It has just basically just this one parameter and two input data, the market return and the risk-free rate. And where we now, if we model finance with an AI, with neural networks, we have this here. We have, instead of one parameter, we have 60 million parameters. Or here's another example. We have billions of parameters. And that's one of the reasons why we need trustworthy AI. Because if we have billions of parameters, it's impossible for us at the moment, human beings, to actually understand what this model is doing. It's just not feasible. And here's the initial setup of such a neural network. You have the input data, you have some weights, those are parameters, the computer is computing. You mix them up, you sum them, weighted sum, you transfer them to something, in this case, +1 or -1. That's supposed to model our brain, because you have some input data, lots of input data, you mix them up, and then you only react to that input data if it's, in this case, greater than 0, you trigger a signal, +1. If it's less than 0, you don't trigger a signal. And if you make it more complicated, it looks like the picture we've seen before. Do a weighted sum here, you trigger a signal, do a weighted sum of the signals, and so on, and then you have the output layer. So that's AI, one way of looking at AI, this kind of neural network. Now you will ask, in the definition there was taking an action. So at the moment there's no taking an action. There will be an output +1 or -1, or the output will be a probability 10%, 20%. You still have to, on top of that, you still have to, the human being still has to decide what kind of action do I take if the output is +1. And in my, I'm a mathematician by training. In my world, all this AI, everything you hear about self-driving cars, recommender system, Amazon, AI, neural networks and deep learning, those are just functions. It's a mathematical, it's just a function. It takes an input and it produces an output. And the difference to traditional world is it's not just a linear function anymore. It's just a very highly complex function which we cannot write down anymore. Yeah, that's it. That's my quick look at AI from a mathematical point of view. There is some nice theoretical result. Since it's a function, if you have any arbitrary function, any complex function in the world, then which describes our world, then you can actually use those neural networks. That's why they are so successful. If that theorem wouldn't hold, we would not talk about them. So they can approximate almost any arbitrary function. Igor, that's it from my side.
Okay, thank you, Dr. Joerg. So now we can move on to the final and third presentation from Dr. Dalila. And yes, now Dr. Dalila, the stage is yours.
Okay, thank you. Well, I'm the last. I think I will briefly. Sorry. Well, I'm from Guimarães, the north of Portugal. Guimarães is the crowned city of Portugal, and today, 24th June, is day one of Portugal. It's a local holiday. So the people from Guimarães don't work today. I'm also a postdoc researcher at the University of Minho in the ALGORITMI Center, and I'm responsible in the intelligent system group for AI applied to the education system. Why I'm the responsible for the AI in education is because I have two PhD. The first one was in education science, and the second in artificial intelligence. And I try in all the work and the research I do apply this AI in education systems and to improve the students and the techniques for education. So my main activities are behavior analysis, human-computer interactions, and also human action recognition. Begin with AI, the main concerns that we have, and based on the with the webinar of ethical consideration for system design, I was reply that the sentence that tell that as the use and the impact of autonomous and intelligent system become pervasive, we need to establish societal and policy guidelines in order for such system to remain human-centric, serving humanity values and ethical principles. And in the right side, we have a picture from the New Yorker at 2 years ago, almost 2 years ago, that present how the technology are present in people, how people interact with technology. So for that we have AI in all application that normally we contact. So we have some practical risks that begin with bad data when we have, for example, a lot of data, but the data are not correct dimension. We have also bad data and that imply bad outputs. We can have also malicious data. So in the output also we have malicious outcomes. And it's important to have transparency because the black box that normally we have an input and we have the output and we don't know what is done in the black box. So it's important to have some explanation about what's happened inside the black box. And also some issues that AI system is not transparent, so it could be not predictable, and people can be afraid from what's happened with the systems that use AI. We can also tell that we can apply responsible AI, and for example, from a researcher from Microsoft, Salema Amashi, he said that responsible AI is really all about the how. How do we design, develop, and deploy the systems that are fair, reliable, safe, and trustable? And to do this, we need to think of responsible AI as a set of societal techniques problem we need to go beyond just improve the data and models. We also have to think about the people who are ultimately going to be interacting with these systems. So when we talk about responsible AI in society, it should be taken into account, for example, AI applications that are systems that are designed and created by humans. They are in really artifacts. We have also to guarantee and make sure that its proposed, the first objective for which each was built. And also we will need to guarantee that we want that technology. Some key issues are needed for this responsible AI in society, that is data, autonomy, learning, and also other factors that we can also think that in many application areas, as we see, AI systems are better than humans. So if AI systems are better than humans, normally we will go apply the AI system. So there are some issues. These issues are important to accomplish. In the responsibility of AI system, it needs to be designed in applying the design in three different views. We need to think in design, we need to think by design, and we need to think by design of designers. When we talk about responsible in AI system in design, we need to ensure that the development process take into account ethical and societal implication of AI. When we talk about by design, we need to think about integration of ethical, reasonable abilities as part of behavior of the artificial autonomous system. And when we are talk about for design or for designers, we are talk about research integrity of a researcher and manufacturer, and also about the certification mechanisms. The three main principles for responsible AI are accountability, that are the ability to explain and justify its decision to users and other stakeholders. Also responsibility, the role of people themselves in their relation to AI system. And also transparency, the ability to describe, inspect, and reproduce the mechanism through which AI systems make decisions and learn. Also will increase the trustworthiness in the system and explicit and open about choice and decision concerning data source and the development process and the stakeholders. So AI system should be developed with the responsibility and incorporating social and ethical values. So when we talk about autonomy, we imply responsibility. When we talk about adaptability, we talk about also transparency. And we talk about interaction, we think about accountability. We need also the explained AI, why we need the explained AI. So today we have a black box, and we have the input features in the model, and we have the output. For example, in the figure, in the image in the left, we have the output is this is a cat. But the user can ask why the system gives us the information that it's a cat. What he have seen to told that is a cat. Well, the system tomorrow, some things that we made to do is explain some explainable AI. Normally that we can begin to input the system is that, for example, This is a cat because it has fur, whisker, and claws. Well, but that is not a global explication because we have other animals that also that. Why they choose a cat in for example, a dog? Okay, that's not very explainable AI. So we need an AI explainable that explain that we are here and why we are here, and explain and interpret the model that you use in order to the user understand and trust the system. Some principles for AI development, for example, the Barcelona Declaration for the proper development and usage of artificial intelligence in Europe. It was prudence. The leap forward in the AI has been caused by a maturation of AI technology, but we must be aware of the still existing limitations. Also, the reliability, that's determine AI system reliability and security, particularly in domains like medicine or autonomous robot. Also, accountability, responsibility, constraint autonomy, and the human role of the system critically depend on human intelligence. So, responsible AI and Dignan in 2019 said that it's about human responsibility for the development of intelligent system along fundamental human principles and values to ensure human flourishing and well-being in a sustainable world. So for the human well-being, we think about the technical issues, and then when you think about technical issues, we are talking about validation and test, data provenance, reliability, explainability. When we talk about societal issues, we talk about shared prosperity, democracy, fairness, privacy, safety, and security. And when we talk about legal issues, we talk about auditability, adherence to law, redress, and ban on military use. And we talk about well-being in general. We are talk about accountability, responsibility, and transparency. What's the trend of AI? So AI confluence with other emergent technology, namely, for example, blockchain, IoT, quantum computing, and others. We have also emergent technology in school, like virtual reality and augmented reality. Wise AI, values learning, anomaly detection, and others. And also AI with ethicals or ethical AI. And we have some initiative on ethics, for example, the E3Es, Global Initiative for Ethically Aligned Design of Autonomous and Intelligent System, legal accountability, transparency policies, embedding values into AI applications, and also governance frameworks. And we have the Europe High-Level Expert Group on AI. The guidelines as a framework for trustable AI, for example, for the Europe, we have a document, we have some with a framework of different levels of trustable of AI, and also all the guidelines or the contributor of each issue and how it relates with the others issues. For example, from the OECD, we have a framework tool for trustable AI. It's a framework high-level structure that is done, and they use also in the system that apply this type of framework. Finally, to conclude, we need a trustable AI, we need explainable AI, but we don't have to forget that for the only way to discover the limits of the possible, it's go beyond then into the impossible. And for that, we need data, and we need to assess to the data to have results, to have some outputs and better system. Thank you. Sorry.
Thank you, Dr. Dalila. So now we have completed the first part, the 3 presentations, and the questions are starting to come. So we will start by the first questions. And I would like to remind again all the attendees that you can ask any question in the Q&A or in the chat. It's up to you. So let's start by the first question. And the question is very straightforward. It's just, where are we in terms of AI standards right now? So I would like to invite Dr. Clara to start.
Yes, thank you. So as I mentioned in my presentation, we have at IEEE, we have been developing these standards for 5 years now. We have already some which are finalized, some are still in development. So from the finalized standard, I would like to highlight the one on value-based design, which came out very recently. As a matter of fact, in my presentation, which might be shared later on, I provided a link to our collection, if you want so, of standard-related activities. So there are already standards there which can be used. And there are some, by the way, all the working groups are open. So if you are interested to participate in IEEE, it's very easy. You don't need to be a representative of a government or something like that. You can participate as an individual in most of the working groups. So this is from IEEE. There is actually, if you're interested, the STAND ICT is an EU-funded project. So if you Google STAND ICT, you will see the latest publication, again, came out 2 days ago, which they make a landscape of AI standards. You will see there that IEEE is very well represented, but there is, of course, ISO, IEC as well. There are some corporations. So we have also started a working group with Sensenelec on data governance, basically, so a lot of, let's say, complementarity. I think that there is a lot to be done, and I think that there is enough place for a lot of standard-setting organizations, and a lot, of course, also to kind of de facto standard, especially in this new phase. I think that there are going to be also new players who are going to that develop already certification schemes and de facto standards as well. But as I said, from adopted standards, I think IEEE is the first, but there are a lot of working groups which are looking into different aspects, from technical and social technical as well.
Thank you. Yes, so now I would ask Dr. Joerg to answer the same question.
Thank you very much. So in terms of standard, I would like to extend that slightly. The question, do we actually use AI models in the finance industry? Because once we have standards, the question is, can we actually use them? And here the answer is very clear, no. My personal experience, we had this very large EU-funded research project, and looking into AI, we went to the Swiss regulator, and it was a very high-level board meeting. So we went there and we wanted to discuss with them. And basically they said, well, it's not in the law yet. Banks are not allowed to use AI models at the moment. So then, following up on Clara, the hope is once we have standards, then it first has to make it into regulations. And then maybe banks are allowed to use them. At the moment, the reason why they're not allowed is to use them is that any decision which is made, let's take a simple decision, deciding on a loan, on a credit, they need to be able to explain why that was made. And with existing AI, neural networks, deep learning models, it's just very, very difficult to do that. Yeah, but in terms of standards, yeah, well, we need them, but I'm a bit skeptical because that's just the starting point. If we go to the traditional models and we have seen those thousands and thousands of pages of regulation, my question would be, instead of answering, my question would be, how much regulation will we need? Millions of pages, or how to go about that?
Yeah, I would say that probably we need another AI to write the pages to regulate the other AI. I think it's more like that. So finally, Dr. Dalila, I don't know if you want to answer.
Yes. Well, we have to have some attention, because when we have some regulations, sometimes, especially in the research centers, it's very difficult to assess the data. Sometimes we are found, we have a project that has a national fund, and we don't have the data because we don't have permission to assess the data. And for that, we cannot have results or good results, because sometimes it's need to create artificial results, and sometimes we contract. For example, if you want a data set, we contract actors for create a data set, and that's not the real world. And the results that we have, the system that we obtained is not a very good system, because we don't have access to the real data. I think it's also important. I know that privacy and anonymization is very important, but we have to balance all these two things.
Okay, thank you, and thank you for referring that part about the access to data, and especially in the business in the business world. And this would be a perfect moment to introduce the other question, which is a big trigger for companies, other than mandatory compliance to regulations, is return on investment. Can you give examples of positive returns, money, for example? Let's say each euro invested can become how many euros by applying that? That companies in different sectors can get by adopting trustworthy AI models. And following the same order, Dr. Clara.
Sure. So I think that when the aim is to align with the values of the potential customers, then I think that you also have a better value proposition as a company. And there are, so coming from our use cases, I can give you just one, for instance, a telemedicine application, which initially, let's say, was a little bit fast thinking, let's make a telemedicine, let's connect patients with doctors, and let's monetize the data. So when there was this value-based design and looking into what customers actually wanted or patients actually wanted, then the most important thing was privacy, and the second one is access to good doctors, to experts. So it was a redesigning, if you want, of the platform, and making it possible to connect really people to specialized experts, and having another financial model, such as subscription or pay by, let's say, by a service, which made, after all, the portal also more attractive for both for doctors as well for the customers. I think that you can see, I mean, already, I mean, talking now, it's not AI, but about, you know, our WhatsApp applications, and you have one model, WhatsApp, and you have another model, which I think is in Switzerland, Threema, which is about really encryption and not having data minimization, and which is constantly growing. It's a sustainable development, not growing exponentially maybe, but it has a very stable customer base, and you see always with each scandal they have more and more. So I think that more and more people will be interested in these ethical aspects, and if there is any service on the market, they will use it. Very often we don't have, unfortunately, any alternative to existing services. But I think that once this people get more aware of possible problems, these new services will have more and more attractivity.
Thank you. It's a very clear, crystal clear answer. So next, Dr. Joerg.
Thanks a lot, Igor. So I have a few small private examples. We are working a lot with the industry, with larger companies and banks, but we also work a lot with startups. And the personal story is a couple of years ago, 2 guys from the US based in San Francisco, they contacted me, well, we want to build this AI asset manager. Do you want to help us? And I was just talking to them a little bit, and the outcome was they are selling AI, but they don't use AI. They just use traditional models and repackage them. 5 years later, they now got seed funding of 100 million. They moved to New York and they are hiring hundreds of people. Of course, I cannot say the name now. And then the same in Switzerland as well. So that seems to be a business model for small companies. Now, jokes aside, can I share my screen?
Yes, let me just allow it. And in 2 seconds, you are the presenter.
Yeah, thank you. So if we go to, yeah. Oh, now I can see. So if we go to large companies, what we really see and what we have seen, and I think after Corona, that's even more so, what we have seen in 2006, the 10 largest companies by market capitalization worldwide, they were traditional companies, car making, Toyota, gas and oil, some bank here, 2 banks. And then if we look at those companies that have a data-driven business model, and those are usually the ones we also connect with AI and machine learning, and then of course Microsoft, but then in 2011, 3 out of those 10, and then 2017, 7 out of those 10, and those are the traditional ones, which we know that they are dominating the AI market, right? I mean, we know Google, Alphabet, Amazon, Facebook, then in China, Alibaba, Tencent, they're really dominating the AI market. And those are the players which decide on what models and how to apply them. And then if we go to finance in terms of money invested, we have lots of different areas where AI can help a lot. So we have credit scoring. AI can really help. You probably know that story. So if you want to get a loan, you should not do it at midnight, because the new lending platforms, they will analyze the time when you're asking for a loan. And if you ask it at 2 a.m., then there's some trouble. They will also analyze the mobile phone you're using. If you use an iPhone, it's more likely to get a higher credit loan than when you use some other cheaper model. So that's why you can use machine learning in AI for fraud detection. 10 years ago, when I was at Goldman's, I built an internal model where our compliance team at the end of the day could identify the 10 trades out of millions of trades, which they then should look at manually, which a lawyer then looked at, whether there was some internal trader which did some front running. 10 years later, this model doesn't, and it was just a simple formula. This model will automatically tell you much more and analyze those millions of trades automatically, instead of the lawyer looking at them, at those 10 one by one, because the human being could only look at them one by one. And then you have trade execution and so on, derivative hedging. There's also another savings element here. You have hundreds of people working in this field nowadays. Once you have your deep learning models, you can you can really get rid of, you can fire many of those people. I was working in algo trading. When I started, we had 100 traders. And when I left, there was only 2 traders left because everything was taken over by machines. But on the other hand, you had 100 more people from IT and quants, but they are cheaper than the traders, so there was still some savings.
Sure. When you say things like if you put your application with an iPhone, you have more likelihood of having a better credit is higher. Do you think that could be one of the problems with using AI, like a bias that is inherent to those models that make those decisions?
Yeah, so the first question I would have is, why not? I mean, it seems reasonable, right? But the reason why you're asking is we don't feel comfortable with that, right? I don't want to be judged whether I use an iPhone as a human being, whether I should get this loan or not. So I think there's there might be some truth in it, but there's the risk of getting it judged incorrectly. 20 years ago, when I wanted a loan in my small village, I went to my neighbor who was working at the bank. We also know each other, right? He knows what I'm working, how my situation is, my personal situation, my job market situation, so he could judge that. But there was also a lot of personal judgment involved, but I felt more comfortable because it was a human being doing that. So maybe that's the reason for your question.
Yeah, yes, maybe the problem is not new, but when you have a person that makes a biased decision, you have someone to account for it.
Yeah.
If it's a model, there's no accountability, because if a model decides which should be my credit according to which phone I use, if I'm a man or a woman, if I live in Portugal or in Switzerland, that would be, I think, one of the problems for the need of trustworthy AI, is that you should know what are the variables that are being taken into account, and some of them are not ethical, right? I'm not saying we can solve this quickly, but I think that's one of the problems. I think you agree.
I had lunch with a very senior executive from one of the 2 large Swiss banks, and he's in charge of all the models, among others, in charge of all the models and the model risk and model validation. And what he told me is, well, in the past it was easy. Who is responsible for the loan decision? It was the credit officer. And now the question is, which team is responsible for the model risk? Is it the model, the quant? The quant will say, oh, no, I'm just a mathematician. Is it the model validation team? They said, battery is running low. They said, no, it's not us. So he's now really struggling to find a person responsible in the company for those new AI models. So, yeah, that's a good point. Yeah.
I would just like to add something, which is basically, I think, of course, there is a huge need for trustworthy AI, and one of the big reasons it's ethics, of course, and this is the one of the biggest walls behind today and the future with AI everywhere. But I think for this case, in which Joerg just went to the local credit, it's basically, if we have such a model of AI evaluating these everywhere in all the times, it's like we are not, I mean, we are getting the same as and probably even less judgment than for a personal credit, a personal face-to-face with another human. However, we are losing our power of decision, because if I want a credit and I know that that some friend of mine works in a bank and I don't want to go to that bank, I can go to another town, to a different bank, and they don't know me. But if we are playing with AI models, they are everywhere all the time. So I can go to the bank X or the bank Y, they will use the same model, or at least the same parameters of the model, and we have no other way to get the creditor. the credit. If I don't like iPhone, for example, which is not the case, for just in case, if I don't like iPhone, I will use Android for all my life. However, I will have like a shorter credit score just because I prefer Android and not iPhone. I mean, these are just the ethical
Igor,
questions
that is not that bad, because if you are a woman, it's harder to change than change phones.
Yes, but I mean, but this is one very practical and very easy example to give.
Yes.
It's just a matter of choice.
Yes. Maybe Dalila can also give her input.
Well, can I share my screen, please? Sorry.
So
yes.
Right away you can.
Okay. Well, I have this image, and sometimes it's important to have this image in the industry, and this forecast for the source, and that is BBC, that explained how the enterprise grew up in the 5 years long, okay? And there are the millions of dollars that they went using each one systems, okay? System that normal use AI, okay? And we don't have names here, but we have that a lot of enterprise companies use this system to apply to their companies. If we want to trust, when this enterprise apply these systems, they trust in the systems. However, like you have said, the AI, when we use AI systems, the problems are always the same. The machine or the system look to the parameters and apply the same rule for all. But when we are talk with the humans, sometimes the conclusion that we have is not the same. That depends on the person, the emotional state of the person, and the decisions are different along the time and different situations for the same problem. So if we have a good AI system and if the people trust that in the system, I think we have more good decisions because the decision has always based in the same principles. Okay.
Okay, and that summarized the second question. And now I would like to answer to ask you the third question, which came from the public as well. And the question is, how can we handle the typical trade-off between complexity and interpretability in future applications? So I would like to invite Clara to start.
Yes, well, I think it actually relates also to the question before. So it's also a choice of what complexity we want. Very often we see, for instance, I will give you an example. There was a research paper which was very controversial, that basically you feed the system with a lot of data, and one of the data was really the facial, characteristics of someone's face, and deducting from there if the person is criminal or not. They claim that they have a 97% accuracy. Now, this has also a question on the technical side, which was controversial, but it has, if you take a step back, it comes to what Katarina said before. Do we want this kind of things? This is something which came back, in the phrenology, which was banned, if you want so, as being unserious research. You can't really deduct if somebody is criminal from looking at his face. So very often you actually need to take a step back, and it's important to have then this transparency. I would completely agree. It's the only way to control these kind of things. And then the question was really about, do we want to have this kind of complexity, or do we want to have, more easier like linear decision trees or something like that, which of course gives an easier way for interpretability or explainability. And coming back to the EU regulation, I think it's important also to see what do we want as to be explainable. Yeah, so very often you need a different set of transparency depending of where you are. You need, for instance, if you have a robot for your elderly care, of course you need to know why this system is proposing a certain medicine, but if it's a completely different transparency, if you're system engineers and you want to repair that system. Again, I come back to what I said. It's important when we speak about these things to speak about the context first, about the use, and then to decide what we want to have in terms of privacy, transparency, and complexity as well.
Okay, Dr. Joerg.
Yes, can I share my screen again, if I may?
Yes. You can now.
So the question is complexity and interpretability. Why do we think about that? So that's one picture, is because at the moment, our new models which we have, the machine learning and the deep learning models, they have some input, and right now they're considered as a black box, and then we have the output. That's why we need the interpretability or explainability. And here another reason is actually the regulation in Europe is the GDPR, which we haven't talked about yet, the data protection. So here it says that subjects have access to meaningful information about the logic involved, as well as the significance and the envisaged consequences of such processing for the data subject. Now, that's not only the regulations. When I was a quant, I built also, in my opinion, very nice trading models, but then I had to go to the trader and explain it to him. And I had to explain it in a way that it was very simple and easy to understand. So I couldn't even build complicated models, because we want the simple models. And we don't want, that's the German regulator, we don't want the black box excuses. We need explainability and traceability of models. Now, what's the downside of that? So, well, first, before we go into that, do we actually need that for all models? Do we have problems? So there are some models, machine learning models here, multivariate linear regression. It's very easy. You have the data, and it's very easy to explain what happens if input X1 changes. You have W1, and then it's very easy to explain what's going to happen. So some models are just straightforward. Here's another example, the decision tree. Think about the loan decision. If your income is above Y, yes, then go left. If the value of your house is above Y prime, then go left, and so on, and then you end up here. So there are some machine learning models where it's easy to understand. Or here, the same thing, you just split, go left and go right. Now, of course, we don't need that here. However, when you go to more complicated models, here on the x-axis, you have the model interpretability, and then the model accuracy. We know from the Vasa, from the Sweden example, linear model is not enough. We need complex models to describe reality. So here you have simple models, rule-based learning, go left, go right, linear regression, decision trees, and so on, all the way up to deep learning, where you have a high accuracy, complicated models, but your interpretability is very low, right? So that's the And the question was about the trade-off. The answer is, I don't know. I just know if you make it more complex, then we have more difficulty in explaining it. And there is a lot of research going on in this explainable AI, trying to explain those models.
Okay, Dr. Dalila, can you?
Yes, well, I agree with about what Clara and Neppel has said. We need to have different layers of transparency and apply this transparency for that depend which people we are talk or explain the model. If are for doctors in medicine, maybe the layer explain more detailed the model. But if you apply, for example, for the same example that Clara has said, for example, engineer, well, the explainable and the transparency is very different. Okay, so we can have different layers of explainable and transparency in the model. Depends on the situation. But I don't know if this is done in real scenarios in this moment. But it's ideal that to be done.
Okay, so just another question we got from the public, which is relating to the difference between interpretability and explainability. Do you have experience in real models that are working in real situations? And following the same order, Dr. Clara.
Well, I think that, you know, the more symbolic type models, they are inherently interpretable, as mentioned before. And the field of explainability and the deep learning is an open question. It is a research problem, actually. So here, I would say there is still, of course, a layer to that, because you have different design decisions, if you want, so that you can explain, let's say. So you can say what we just mentioned before. What is the data? What data categories were used? What kind of what is the optimization which underlies the neural network? And so these are already some levels of explainability, if you want to, transparency. There is then, of course, a problem on the individual level. Of course, why did you tell me exactly this? Which, as I said, is an open question. There are some progresses there, but I think this is the bigger, you know, as DARPA is one of the big DARPA projects and so on. So how to make neural network also inherently, if you want, some more explainable. But if I can give you just one example, sorry for that, because even in Vienna, so we are based in Vienna, so there there was an example of an employment agency who basically categorized unemployed people into different the prospectus of getting employment and having different services. And it was a very transparent model. It was basically based on a known function, which took into account the neighborhood, you know, age, and so on. So even if people were able to look into what happened, it was very controversial. So people said, this is something that we would not like to have. We would not like to have someone being, you know, judged on a prospect of getting employed based on a neighborhood. So even if it is very transparent, it can have ethical aspects. If you're very transparent and you know what the result will be, people will object. The good thing is, if you have a transparency, they have a chance to object. If you are completely opaque, it's going to be more difficult.
Okay, thank you. Dr. Joerg?
Yeah, so in terms of real models, I mean, we have a lot of experience with machine learning models. They are used, as I said, in finance. It's still difficult to use them, but everyone, we have lots of research projects, so everyone is looking into that. But the challenge there is still, are they better than existing traditional models in that area? We know many areas where they are better, right? I mean, that's why we are here. They have been extremely successful, self-driving cars, all those things, Amazon recommender systems. Just for finance, I think there's still a huge challenge, and that goes down to the data issues. We have a lot of unstructured, very, very noisy data. Financial market data is very noisy, so that's another thing to take into account. I have one comment which I wanted to mention earlier to basically to what Clara and Dalila said, in terms of what are additional requirements we need on the model. We need a human oversight and so on, so the EU requirements. So the personal experience is, in finance you have those internal, every bank can decide to come up with their own internal model how to calculate risk. So if you want to calculate credit risk, UBS, Credit Suisse, they can say, okay, I come up with my own models. The consequences, they hire 100 of quants to come up with the best possible model, and at least in Switzerland, for making loan decisions, the risk capital they had to keep on the bank account for potential future risk was half as much as from smaller banks. But they had exactly the same risk. They were giving the loans to the same people, to the same incomes, but their models were just better. And then after the financial crisis, the mood has changed. Then the focus is much more on the process. It's not on the model. They need to show on the governance who is actually responsible, who is accountable. Is the headcount large enough? So one bank, they then had, given by the regulator, they said, okay, you need to hire 300 more people in that department. That was the requirement. Hire 300 more people. It's not, I mean, checking, it's just the government. So that's the governance. That's a lot of focus on that, right? Maybe that's the solution. If we cannot check the model and cannot explain and interpret that, maybe we need the standards, the ethical considerations, and the process in place which is checked. How do we develop the model? Does that make sense?
Exactly, and start by a lower level AI, exactly, by the ethics, and then starting to build, and not just what companies are trying to do, which is going from a no AI to just a deep learning AI, which they don't understand, we don't understand. It's not ethical, it's not nothing. So finally, Dr. Dalila, if you want to intervene.
Well, I think explainable AI are in the beginning. There are some works that are doing, but we have a great challenge in the future to have systems that are explainable. We, for example, in our group, we have work with, for example, with detect violence and inside the car, and we have used an explainable system based, for example, in the very consistent logic to explain if violence occurred or not, and why violence occurred or not. And it's very previous conclusions with this system. So the literature and also what we have about explainable and how explainable the system can be, where I think we have some years to have better system in this area, because it's very challenging and very and now it's very difficult to have a good results for people and how people and understand the system.
Okay, so about the questions, so we are just about to hit the time of the session, and by saying that, I would like to thank you again, all the three speakers, to thank Katerina and Pedro for being here, and also, of course, all the attendees. And yes, if you have any final considerations, I would like to invite you. in no specific order if you want.
Well, thank you for the invitation. I think that these already these discussions are very important, and to raise awareness, and then hopefully, you know, also be active. I think that you've seen a lot of examples if you are interested, where you can get engaged and discuss this further. Thank you.
Yeah, from my side also many thanks for the invitation, and just maybe one final comment. We talked a lot about trustworthiness and being skeptical about those models. I think we should be super excited in the times we're living now, not in the time of the 17th century with the linear model and the ship sinking. Now we can actually explain our complex model, our complex world. And the reason why we need those complex models is because our world is so complex and our brain is so amazingly good. One thing we didn't touch on is energy consumption, which we talk about for Bitcoin a lot, but we don't talk about for deep learning models. Running a deep learning model uses a lot of energy. Our brain can do the same things much more efficient. So we are still far away from our brain, but that's amazing, I think. Okay, thank you.
I guess we just need sorry Dalila.
No.
We just need a funny thing. We just need the power converter from Back to Future, and then we can get food and feed the deep learning. Okay, Dr. Dalila.
Thank you for the invitation. I think it's very important to have this meeting because there are a lot of challenges to be solved in the future, and I think we discussed that and have some different opinion. I think it's very important. Thank you.
Okay.
Hey, Catarina and Pedro.
Just say thank you all for taking the time to be here, for the speakers, especially Dalila. I didn't know it was a holiday in Guimarães.
Yeah, in Braga is holiday. In Braga is St. John, but in Guimarães is day one of Portugal, the first day for Portugal.
Okay, thank you very much, and thank you all the attendees I hope it was helpful for you and for all the questions that were said. Thank you, and hope to see you in the near future with more answers than questions. I think we are evolving a lot, and I think in the near future we have more answers to these challenges. Thank you.
And hopefully not virtually.
Thank you. Bye-bye.
Thank you. Bye.
Thank you all.
Thank you.
See you.